The instrument panel master control is, in today's terms, the operator interface with the air conditioning system. On manual and semi-automatic air conditioning systems, the master control includes the temperature control selector, the mode selector, the blower motor fan switch, and a separate air conditioning on-off switch. On some vehicles, the on-off switch is a part of the mode selector. The temperature control selector has separate functions for heating and air conditioning. In the heater mode, with the full hot position selected, the temperature selector operates a heater control valve, either directly through a cable or through engaging a vacuum switch. The effect is to open the heater control valve to allow coolant to circulate through the heater core. As the temperature selector is moved from hot towards cold, the amount of coolant circulating through the heater core is reduced. At full cold, the flow of coolant is minimized in most systems. The flow is not entirely shut off because a small amount of coolant flow is necessary to provide a relative humidity, and the warmed air will raise the humidity. In the air conditioning mode, the temperature selector controls the thermostat for the air conditioning system. The thermostat setting adjusts the points at which the compressor clutch is engaged and disengaged, depending on driver settings and the evaporator temperature. The air conditioning thermostat will still go through the compressor clutch setting adjustments when the system is operated in the heater mode, but since the air conditioner is not on, the adjustment of the thermostat will have no effect on performance. The mode selector of the master control allows the operator to set the direction of the air distribution as well as to select different operating systems. On most vehicles, the mode selector will allow the operator to choose between heating and air conditioning and to choose between defroster, center vents, floor, or bi-level air distribution. On vehicles that do not have a separate air conditioning on-off switch, the mode selector completes that task whenever air conditioning, defrost, or recirculation modes are selected. The master control includes a fan speed selector switch to allow the operator to vary the volume of air that is discharged through the outlet ducts. Most blower motors operate on 4 speeds from low to high. The speed of the blower motor varies through the use of a blower motor resistor block. When a fan speed is selected on the fan switch, current is routed through the switch to one of 4 terminals on the resistor block. The low-speed circuit passes the current through the highest resistance to result in the slowest blower motor speed. The second and third fan speeds have progressively lower resistance to cause the fan speed to increase. The high fan speed has the lowest resistance and is the default value. If a blower motor resistor fails, the fan speed will usually only work in high speed. In addition, on vehicles with the recirculation mode, the fan switch is overridden by the mode selector and the blower motor runs on high speed. The vehicle operator can choose where he or she wants the air to be discharged from by use of the mode selector switch. On most vehicles, the mode selector switch controls the distribution of vacuum to the vacuum control doors that direct the flow of air to the defroster, center vents, floor, or any other offered positions. On most vehicles with gasoline engines, a vacuum storage tank that is connected by a hose to the intake manifold supplies vacuum to the master control. On diesel engine vehicles, the vacuum tank is supplied by a vacuum pump. The mode selector on the master control can either send an electrical signal to a programmer that controls the distribution of vacuum to individual vacuum actuators, or it can directly operate a vacuum distributor that does the same thing. The vacuum actuator is a diaphragm-controlled bellows. On one side of the diaphragm is the vacuum source. On the other is an adjustable rod that is connected to an air distribution door. As vacuum is applied to one side of the diaphragm, the rod is pulled towards the vacuum source and the air distribution door is opened to allow the airflow through the ducts that the door controls. When vacuum is cut to the diaphragm chamber, spring pressure forces the rod out to close the door. In addition to the air distribution doors, the mode selector also controls the position of the air blend door for heater operation and the position of the vent air door for fresh air intake when neither heating or air conditioning modes are selected. Some vehicles will use cables to operate temperature blend and vent doors instead of operating them by vacuum. On mechanically operated doors, the position of the door can be adjusted by adjusting the cables. Automatic air conditioning systems differ from manual and semi-automatic systems in that they are microprocessor controlled. Rather than using a thermostat, the automatic air conditioners rely on sensors to monitor the in-vehicle temperature and operate the compressor and air distribution system to maintain a preset temperature. The control panel of an automatic air conditioner can either be a manual, push-button, or touchpad display that allows the operator to select a temperature for the heating and air conditioning system to maintain. The microprocessor is referred to as a body control module, or BCM. It uses electronic sensors as inputs to determine the amount of heat or air conditioning required to maintain the temperature. The common input sensors of an automatic air conditioning system are the ambient temperature sensor, sun load sensor, interior temperature sensors, low pressure switch, low side temperature sensor, and high side temperature sensor. The ambient temperature sensor is an external temperature sensor. The sensor is a thermistor that provides input to the body control module so that a calculation of the difference between the outside and in-vehicle temperatures can be made. The sun load sensor is a photovoltaic diode that sends a voltage signal to the BCM as an input on the radiant heat entering the vehicle through the surrounding glass. The in-car or interior temperature sensor is usually a tubular aspirator that draws a small amount of air through an inlet and sends a corresponding temperature sensor to the BCM as an input signal. A high-temperature switch is located on the condenser outlet to sense the refrigerant temperature. Though it is a temperature sensor, the BCM uses the input to calculate system pressure based on the relationship of temperature to pressure. Similarly, a low-temperature switch is used on the low side of the system between the orifice tube and the evaporator inlet. The low-temperature switch valve is again recalculated by the BCM to determine system pressure. Some systems also use an evaporator thermistor as a BCM input to control evaporator temperature. Based on operator input and sensor inputs, the body control module controls the operation of the compressor clutch, blower motor speed, and air distribution and blend doors. While the operation of the blend doors and compressor clutch is automated, the principles of operation are the same as with manual and semi-automatic systems. On automatic systems, the vacuum and electrical circuits are continually monitored and activated by the BCM instead of the vehicle operator, or the thermostatic and pressure controls. The one difference is the operation of the blower motor. On automatic air conditioning systems, the blower motor is controlled by a power module that varies the current to the blower motor. The blower motor operation on automatic air conditioning systems is infinitely adjustable and is varied by the BCM in response to load demands. The power module is also the main control for current to the compressor clutch. Another difference on automatic air conditioners is the use of electric mode actuators on some systems to position the air distribution doors. This allows the position of the doors to be moved throughout a range of 360 degrees. Lastly, the water control valve on automatic air conditioners is controlled either electrically or by vacuum.